Okay, so first thing we're going to look at is more probability, but this time we're going to write probability more than just as a fraction. We're going to write probability as a fraction, as a decimal, and as a percent. So the first part gives us our background. In a bag of letters, there are 3 A's, 4 B's, 7 E's, and 1 H. So we're going to write the probability of A, of picking a letter A, as a fraction, a decimal, and a percent. This should say a decimal, not and decimal. Natalie, how many ways are there to get an A? How many A's are there? 3. And how many total letters are up there? 4. How many? 4. No, how many total letters out of all? We've got 4 different letters, but if we count up how many of each letter we have, how many letters total are there? 15. So the probability as a fraction would be, we want how many A's out of how many total? 3 out of 15. Good, 3 out of 15. What does that reduce to? What number goes into both 3 and 15? Anything? No, 2 doesn't, because they'd have to be even for 2 to go into that. So 2 does not. You want to call on someone to help you? Ella, go ahead. 3. So what would this reduce to? 3 goes into 3. Good. 3 goes into 3 once. 3 goes into 15 5 times. So we get 1/5. Okay, now we need to write it as a decimal. Zach, how would I write 1/5 as a decimal? What do I need to do? When we change a fraction to a decimal, can anyone help him out? What do we need to do with the numbers? Hannah?
We need to switch them.
Not switch them. Ethan?
Multiply.
Not multiply, but you're getting warmer. Owen?
You divide them.
You divide them. So we're going to take our calculator, we're going to do 1 divided by 5. Okay, so 1 divided by 5. When we do that, we get a nice terminating decimal. We get 0.2. So as a decimal, this would be 0.2. Now, how do we write that decimal as a percent? Sydney? Good. Move the decimal over twice, and we get 20%. Okay, now we're going to do number 2 together, and then I have some additional ones I'm going to give you to do also. Now we're going to write the probability of not A as a fraction, a decimal, and a percent. Haley, what's the probability that I'm not going to pick A? Didn't quite count them all.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
12, there you go. So the probability of not A is? 12 out of 15. We still have 15. And what does that reduce to, Haley? 4/5. Excellent. Okay, now how do we change that fraction to a decimal, Emma? Good. 4 divided by 5. And again, we get a nice, easy decimal. 0.8. We don't have to worry about rounding or anything like that. Hannah, how do we change that to a percent?
Move over twice and then you get 80%.
Good. Move the decimal over 2 places, and we get 80%. Okay, a couple for you to do on your own. I want you to write the probability of B 3 ways, And then I want you to write the probability of not E 3 ways. So I'm gonna pause this recording that we're doing while you do that. Avery, what is the probability of B as a fraction?
4 out of 15.
Good, 4 out of 15. Does that reduce? Does it reduce, Avery? Does it reduce? No, it does not reduce. Kate, how do I, where's Kate?
This
How
is
do
gonna be
I
a funny
reduce that
video.
to a fraction? Good, 4 divided by 15. And what did you get? 0.27, good. We actually get 0.2666. Is 0.26 repeating? We're gonna round that to 0.27. Ethan, what is that as a percent?
27%.
Good. Move the decimal over 2 places and we have 27%. Talia, what's the probability of not E?
3 out of 15.
What was that?
8 out of 15.
Good, 8 out of 15. Does that reduce, Talia? No, does not. Questions, Alana? You can. Yep, you can. Hannah, question?
I was just gonna answer the next.
Okay, I'm gonna go random here. Tyson, how do I change this fraction to a decimal?
Divide it.
Good. And what did you get when you divided 8 divided by 15? 0.53 repeating. Good, that's what I got too. What would that round to?
33%.
Good, you jumped right to the percent, but as a decimal it would be 0.53. And we can do 0.53. And that is 53%. Okay, any questions about that?
No, that was easy.
Yeah, can anybody hear me on this video?
Okay. We're gonna look at something a little different now.
Alright.
We did these before. In a shipment of bicycles, 7 were found to be defective out of a batch of 250.
Oh boy.
What is the experimental probability that a bicycle is defective? So if we have 7 defective out of 250, how would we write that as a probability? Ella?
7 out of 50.
Good, 7 over 250. Okay, and let's write that as a decimal. Owen?
I got 0.028.
0.028, let's try that. 7 divided by 250, 0.028, excellent. So what percent would that be, Owen?
2.8%.
Good, if we move the decimal over 2 places to the right, we get 2.8%. Now, when we predict the number of defective bicycles, there were 2 ways that we learned how to do this that you can pick from. Does anybody remember one of the ways? Owen?
Wouldn't you round it to 3%?
We could round it to 3%, but it's more accurate if we leave it as a 1/10%, so we're gonna leave it. Okay, do you remember how we can predict how many defective bicycles there are in a batch of 700? Owen?
Don't you add up all of them? Or don't you?
No? Sam, do you have an idea?
Times 2.700.
We could times, actually not 2.8, though, we want the 0.028, we can do it that way. If 2.8% are defective, we can say, well, 2.8% of 700 are gonna be defective. So we can say 2.8% of 700, which means that we need to multiply. So 0.028 times 700. Let's see what we get. 0.028 is still up there. Times 700. We get 19.6. Now we can't have 19.6 bicycles. So how many bicycles would I predict? 20. 20 bicycles. So we'll say about 20 bicycles. The other way that we can do this is through setting up a proportion. And some of you are pretty good at using proportions, so you might prefer this. Can anyone tell me how I would set up a proportion to solve this? I use the ratio that I have, 7 out of 250. Ella? No, I don't actually need to use this at all. I start with my 7 over 250. So I have 7 defective out of 250 total. I'll go on my other side. Owen?
Wouldn't you put X over 700?
You would. We want to know how many are defective. That's our X. So we have X defective out of 700 total. So we have defective out of total, defective out of total. Remember, when we write a proportion, we need to have the same things on the top, same things on the bottom. So the tops are both defective, the bottoms are both total. Okay, now let's solve this proportion. Levi, what do I do to solve it? No, remember this? I'm going to cross multiply, right? So the first part of my equation, I'm going to do 250 times what? Times x. So I have 250 x equals, what else do I multiply? Good, 7 times 700. Okay, I'm going to leave my 250x. Now, what is 7 times 700? You shouldn't need a calculator for this because you can just do 7 times 7 and then add on 2 zeros. Sydney? Not 1400, you do multiply 7 times 7. You add it. There you go, 4,900. Now what do we do to solve for x? Ethan?
Divide by 250 on both sides.
Good, divide both sides by 250. And we get x equals 4,900 divided by 250 gives us, look, the exact same thing. So it doesn't matter which method we use, we're going to get the same answer. So 19.6, or again, we'd say about 20 bicycles. Okay, I want you to try the next one. We have in a bag of 40, 2 potatoes were rotten. So you have a bag of 40 potatoes, 2 of them were rotten. First, find the experimental probability, just like we did up here, and then predict the number of rotten potatoes. Sam, what is the experimental probability that a potato is rotten? Good, 2 out of 40. What does that reduce to, Sam?
0.05.
The decimal would be 0.05, but what would it reduce to if I wanted to leave it as a fraction? Uh-huh. 1 out of 20. Good. Which is 0.05. Okay, now predict the number of rotten potatoes in a bag of 100. Most people were using the proportion model, so that's what I'm going to do. I use the same ratio I used to find my experimental probability. So 2 rotten out of 40 total potatoes. What am I going to put on the other side? I want to know how many rotten potatoes are in a bag of 100. Natalia, what would I put on that side? I need, on the top, I need rotten. On the bottom, I need total. So do we know how many rotten potatoes are in the new bag? Does it tell us, or is that what we want to know? Or is 100 how many are rotten, or how many are in the bag? 100 are rotten? No, it says predict the number of rotten potatoes. So we actually don't know. We're predicting the number of rotten potatoes. That's what we don't know. So that's our X in a bag of 100. So there are 100 potatoes in the whole bag. That's our total. Okay, now let's solve this proportion. Kellen, can you tell me what to write as my equation? Okay, 200 equals 40x. Where did you get the 200? It's right, but where did you get the 200? I just want to make sure I remember. Good. So when she just skipped right to this step, 2 times 100 equals 200. Okay, now what do I do to solve it? What's that? Good. Did you say divide this by 42? Okay. And what do I get? Five. So there would be 5 rotten potatoes in that bag of 100 potatoes. Okay, let's see how long we're still doing well.
I gotta get me one of those.
Okay, let's try this next problem. You pick from a stack of 3 cards, numbered 1 through 3, and you spin a spinner with, oh my goodness, what did I write? With 5 equal sections. Let's just take that off. That should say 4 equal sections. I changed the problem and I forgot to change the other half. Numbered 1 through 4. Okay, so we have a stack of 3 cards. Let's just draw this up here. We have 3 cards, and the cards say 1, 2, 3. And then we also have a spinner. The spinner is divided into 4 sections, 1, 2, 3, and 4. Okay, so yesterday you went over with Mr. Renninger how to make a table showing the sample space. Can anyone tell me how I would make a table to show the sample space for this? Hannah?
Can I come up there and show?
Okay. Might be easier than trying to explain it. There you go.
So what you do is you make the table like this, and then you put the numbers on one side and then on top.
Okay.
So I would probably put 1, 2, 3 down here,
Okay.
and then 1, 2, 3, and 4 up here.
Good. Go ahead and do that for us.
Kind of like a little sloppy.
Okay, now when you do the top, you need like a little space that would draw a line here.
Okay. That,
Yeah, hang on just a second. I'm actually gonna take away one that you made. Okay, draw your line again. Okay, good. Now above that line, write your numbers for your spinner. Good, good. Okay, now go ahead and draw your lines so your table's nice and neat. Okay, so you guys can be doing this as she's doing it to kind of help you remember what to do. So we're putting the numbers of the spinner across the top and the numbers that you can get on the cards along the side. It doesn't matter, she didn't have to do it that way. She could have put the numbers of the cards across the top and the numbers of the spinner along the side. It doesn't matter what goes where, it just matters that you have 2 things labeled. Okay, thank you, Hannah. So now we look at what all of our possible combinations are. So these are our cards. This is our spinner. So we could pick a 1 on a card and spin a 1 on the spinner. So we could have 1 and 1. We could pick a 2 on a card and a 1 on the spinner. So 2 and 1. Or we could pick a 3 out of the cards and spin a 1 on the spinner. And we have the same thing over here. We could do a 1 and a 2,
or 1 and a 3.
a 2 and a 2, a 3 and a 2,
No, it would be
1 and 3, 2 and 3, 3 and 3, 4 and 1, 4 and 2, and 4 and 3. Okay, now, how many possible outcomes are there? So each one of the little boxes in the table is one of the outcomes. So one of my outcomes is that I could draw 1 and spin a 1. Another outcome, I could draw a 3 and spin a 4. Hannah, how many outcomes are there?
12.
12 outcomes. Good. We have 1, 2, 3, 4 across the top, 1, 2, 3 against the bottom, along the vertical. So 4 times 3 is 12. There are 12 possible outcomes. What is the probability of getting a 2? So how many of those outcomes have a 2 in them? Question?
Yeah.
Yeah, the way I did it over here, I probably should have put 1, 4, 2. Let me fix that. Ah, that was bad. That was
You
a
erased my words,
monster
how dare
eraser.
you? You mad genius.
Okay, we're gonna make that eraser really small. Let's erase that. You guys are really good. Okay, so what Owen is saying is I should put the 1 first here because that's the order I went in all the other times. So 2, 4, and 3. Does that look better?
Yep.
Okay. Okay, now what's the probability of getting a 2? Let's see how many have a 2 in them. So this one does not. This is 1 and 1. This one is 1 and 2. There's a 2 in there. This one has a 2. This one has a 2. Ooh, all the ones in the 2 row have a 2, don't they? And all the ones in the 2 column are going to have a 2.
So that would be 6.
Okay, so we have 6 that have a 2 out of how many total? 12. What does that reduce to?
1.5.
1/2. What's the decimal for 1/2? Shouldn't need the calculator for this. 0.5 and the percent?
5%.
50%. We have to move it over 2 places, so that gives us 50%. Okay, number 8 asks us, what is the probability of getting the same number on the card and the spinner? So we have to look at how many of those choices give us the same number. Hannah?
3.
3. What are they?
1, 1, 2, 2, and 3, 3.
Good. We could get both 1s, both 2s, both 3s. We can't get both 4s because there are no cards with a 4. So what's the probability? 3 out of
1 out of 12.
12. What does that reduce to?
Well, you should divide by 3 so you would get 1/4.
Good. And this is another one. You shouldn't need your calculator. What is 1 out of 4? Haley? 0.25. And what percent is that? 25%. Good. Okay, we don't have time. I'm not going to send you on with a take-home quiz yet. I don't think we're quite ready for that yet. So we'll do a little more with this tomorrow.